There is a moment in every great journey when the map stops making sense, when the lines drawn by certainty dissolve into questions, when explorers realize they've crossed a boundary no one truly understands. Voyager has reached that moment, far beyond the planets, beyond the comforting dominance of the sun, beyond the last place we ever expected to collect reliable data. Voyager is no longer traveling through the solar system. It's traveling through the galaxy itself. And what it's detecting out there is forcing scientists to rethink what interstellar space even means. Because this region, this place Voyager is drifting through, is not quiet, not empty, and not passive. Something vast is pressing back. Before we go further, welcome back to Beyond Space. Where we explore the universe one impossible discovery at a time. If you enjoy journeys beyond the edge of the known, make sure to subscribe and join us among the stars. Voyager was never supposed to go this far. Voyager was built to be temporary. In 1977, no engineer at NASA imagined this spacecraft would still be alive nearly half a century later. It was designed for a planetary tour, a rare alignment of the outer planets that happens only once every 176 years. Jupiter, Saturn, maybe Uranus and Neptune if everything went perfectly. Beyond that, silence. Voyager's computers have less processing power than a modern digital watch. Its memory is measured in kilobytes, not gigabytes. Its software was written before we understood plate tectonics on Mars, before exoplanets, before dark energy. And yet, Voyager keeps transmitting. Each signal takes more than 24 hours to reach Earth. A whisper crossing a void so vast that if Voyager failed right now, we wouldn't know until days later. No alarms, no warnings, just absence. And those whispers are telling us something unsettling. Interstellar space is not what we imagined. The galaxy is not empty. For decades, scientists pictured interstellar space as a near-perfect vacuum. A cold, dark nothing separating islands of stars. This idea shaped our equations, our simulations, our expectations. Voyager shattered that illusion. Beyond the heliopause, the invisible boundary where the sun's solar wind finally loses dominance, Voyager encountered structure, dense magnetic regions, charged particles moving in coordinated flows, plasma behaving less like fog and more like weather. Not random, not chaotic. Organized, the galaxy has currents, pressure fronts, shock boundaries, a vast, dynamic environment stretching between stars. Voyager didn't enter emptiness, it entered a system. A galactic current pushes back. As Voyager pushed forward, its instruments detected something unexpected: pressure. Not gentle resistance, but force. The interstellar medium isn't softly brushing past our solar system, it's pushing against it. Hard enough to reshape the heliosphere itself. Instead of a smooth bubble, the sun's protective shield is distorted, compressed on one side, stretched into a long, comet-like tail on the other. Our solar system is moving through the galaxy at over 200 kilometers per second. We are not stationary, we are plowing through a galactic current, and Voyager is riding the bow wave. Magnetic fields that shouldn't be this strong. One of Voyager's most shocking discoveries came from its magnetometer. Scientists expected the sun's magnetic influence to fade gradually beyond the heliopause. Instead, the magnetic field snapped into alignment, stronger, more stable, more ordered. It didn't weaken, it changed regimes. Voyager crossed into a magnetic structure shaped not by the sun, but by the Milky Way itself. This suggests something profound. Galactic magnetic fields may influence how planetary systems form, how cosmic radiation flows, how habitable zones survive over billions of years. The galaxy isn't just a backdrop, it's an active participant. Echoes of the sun years later. Voyager is also detecting echoes of our own star. Shockwaves, ripples in plasma, created by solar storms that erupted years ago. These waves travel outward for billions of kilometers. They slam into the interstellar medium. They reflect, compress, and rebound in complex patterns. The sun's influence doesn't end at a boundary, it collides. And Voyager is witnessing those collisions long after they began. Time moves differently out here. The present is layered with the past. a machine refusing to die. Keeping Voyager alive is now an act of engineering defiance. NASA engineers are working with hardware older than the space shuttle. Commands must be crafted carefully, knowing that any mistake could be fatal. Radiation has flipped bits in memory. Thrusters long thought dead have been resurrected. Heaters have been shut down to conserve power, leaving the spacecraft colder than anything ever tested. In 2025, engineers did the impossible, rewriting failing memory sectors and reactivating dormant systems. Every command is a gamble. Every success feels unreal. Voyager refuses to die quietly. Voyager is becoming a galactic artifact. Soon, Voyager's power will fade. First one instrument, then another, until finally, silence. But Voyager itself will not stop. It will drift through the Milky Way for millions of years, long after Earth's continents rearrange, long after humanity evolves or vanishes. A technological fossil, a relic of curiosity, a message in a bottle cast into the cosmic ocean. If another civilization ever finds it, Voyager will speak for us, not with words, but with evidence that we once reached beyond fear. Why Voyager terrifies and inspires scientists. Voyager proved that the universe doesn't end where our models say it does, that boundaries are not lines, but zones, that emptiness is an illusion, that the galaxy is alive with pressure, motion, and structure, and most of all, that even our most fragile creations can survive far longer than we ever imagined. Voyager is no longer just a spacecraft. It is humanity's first physical interaction with the galaxy itself, and it's still going,